Again, welcome to statistics course. In these lectures, we're going to discuss about the confidence intervals for the mean using small samples. When we say the small samples, we mean the sample size is less than 30. Previous lecture, we used the large samples, which is the sample size either is equal or greater than 30. So our main objective in this lecture is to interpret the t-distribution and use the t-distribution table. Now, when the sample size is less than 30, which is a small sample, we cannot use the standard normal table. We use the t-table. So construct the confidence interval when n, the sample size is less than 30. And also the population is normally distributed, but the standard deviation is unknown. So let's start with the t-distribution. Here we say that when the population standard deviation is unknown, and also the sample size is less than 30, and most important, the random variable s is approximately normally distributed, then we follow the t-distribution. So to find the t-test, it will be the x bar, which is the sample mean minus the population mean, divided by the standard deviation of the sample, divided by square root of the sample size. So the critical values of t, we are going to use the notation TC. So these are the properties of the t-distribution. First, the t-distribution is a bell shape and also symmetric about the mean. So t-distribution also is normally distributed. Now, the t-distribution is a family of curves, each determined by a parameter called the degree of freedom. So degree of freedom are the numbers of free choices left after a sample statistic such as S bar is calculated. And when you use the t-distribution to estimate the population mean, the degree of freedom are equal to 1 less than the sample size. So degree of freedom is always n minus 1. That is the sample size minus 1 will give us degree of freedom. So these are the properties of t-distribution. And the third one is that the total area under a t-curve is always 1, even under normal curve, and the distribution is 100%, so it's 1. Then the mean median mode of t-distribution are equal to 0 because they are in the center, same as standard normal. Also, as the degree of freedom increases, when the degree of freedom increases, the t-distribution approaches the normal distribution. Then here we say after 30 degree of freedom, the t-distribution is very close to the standard normal, which is z distribution. So this is our again normal curve. Degree of freedom is 2. Degree of freedom is 5. We can see how it shrink. And then the standard normal curve. So let's try one example. Hopefully this will make us understand. So here we say the critical values of t. We should find the critical value TC for 95% confidence when the sample size is 15. Now we can see the sample size is very small. So first we go with the degree of freedom. Degree of freedom will be the sample size minus 1, so it's 15 minus 1, which is 40. So based on the table here, we can see the degree of freedom is on the left side from 1, 2, 3 down. Then this is our level of confidence values, the 1 tail and also 2 tails values. So here, when we find the degree of freedom, it was 14. We are looking for the critical value TC. But we have to be careful with the degree of freedom, 14, so we're on the 14th row. then is 95% confidence. So the level of confidence is 95 and 14. So that will give me 2.145. So that's again the way we use the T table. Level of confidence, there's three rows. Level of confidence, one tail and two tail. Then to the left, we have degree of freedom. Then we have the p-values inside. So we know 6.95. So negative TC will give me negative 2145. And TC will give me 2145 also. So here we say the C confidence interval for the population mean. Same formula as we used in the previous. So it will be sample mean plus E or sample mean minus E. And then the probability that the confidence interval contains mu is always C. So this is the steps in deciding whether to use the T distribution or standard normal curve. So first, identify the sample statistics, such as the sample size, sample mean, sample standard deviation. And we can see the formula will be S bar, the sum of all the S divided by N. And also we find the standard deviation, the difference of S and S bar all square. We had all of them, then we divide by N minus 1. So now we know the mean. Identify the sample statistics and S bar and S. Now we're going to identify the degree of freedom, the level of confidence C, and also critical value. So we know the degree of freedom is N minus 1. To find the margin of error, E will be TC S over square root of N. And here we have a S bar minus E and S bar plus E. Now let's say we saw our condition. Now let's see if we can solve this problem with the condition now. So you randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162.0 degree F with a sample standard deviation of 10.0 F. Find the 95% confidence interval for the mean temperature, approximately normally distributed. So first, we use the T distribution. Why? Because our sample size is less than 30. And also we don't know the population standard deviation somewhere. So here, N is 16, the S bar, we do it, we get 162. S is 10, 6.95. So degree of freedom will be N minus 1, which is 16 minus 1, which gives us 15. Then we can go to the 15 section, 15 row. Then we look for 95%. And that gives us 2.131. So TC is 2.131 times S, which is 10, and the sample size square root of 16. So if we solve this problem, we get 5.3. Now next we move the confidence interval. The left end point will be 162 minus 5.3. And the right side will be 162 plus 5.3, which will give us 167.3. So our interval will be from 156.7 to 167.3. So that's the diagram we have here. And in the interpretation here, we said with 95 confidence, you can say that the mean temperature of coffee sold is between 156.7 to 167.3. So next, is n greater than or equal to 30? If it's yes, then we use the normal distribution with E equal to ZC standard deviation by square root of n. Now, if it's no, we have one more question. Is the population normally or approximately normally distributed? If it's no, then we cannot use normal distribution. Now, next, if it's yes, then its standard deviation of the population is no. If it's yes, then we use the normal distribution. If it's no, then we don't. We use the t distribution. So let's see one example here. Here they say whether we are going to use the normal or t distribution. Again, normal, the main objective here is that with normal, we have to make sure the sample size is greater than 30 or equal to 30. But with t distribution, the sample size should be less than 30. So here we say we randomly select 25 newly constructed houses. The sample mean construction is dollars, $181,000, and the population standard deviation is $28,000. Assuming construction costs are normally distributed, should you use the normal distribution, t distribution, or neither of construct confidence interval for the population mean? So here they say we should use the normal distribution because the population is normally distributed and the population standard deviation is null. So this will be our conclusion of our lectures on t distribution. Here again, we're still on the confidence interval, but here we are finding the confidence interval when the sample size is small, less than 30. So again, wish everybody the best. If you have any question, again, feel free to send an email. Also, you can reach me on my telephone. So again, wish everyone the best. Thank you.